you see, there's a half that might be true. And here I am, and I'm standing with a perfect view. I cannot go far enough away from you. I've seen it all before, and I know it's only words. Hello, I can hear it's in my ear. Hello, hello. Hello everybody, welcome to this week's edition of Video Notes for Mr. Flugum's AP Chemistry class. That's right folks, this is for AP Chem. And we're just going to talk about types of chemical reactions and relate that to redox stuff. A lot of this should be review for you guys, but I want to make sure we cover it so that we understand types of reactions and when they are redox and when they are not. So let's go ahead and get started. Well, if you remember back to Gen Chem, folks, and when you talked about chemical reactions, there are 5 different types of reactions, folks. Okay, so 5 different types of reactions, and they are listed for you there. They are synthesis, right, decomposition, single displacement, double displacement, and combustion. And we're going to look at all of these, and we're going to kind of start to evaluate whether they are redox reactions or not. All right, so our first reaction we're going to talk about is synthesis. This is where we have 2 or more substances that combine together to make one new substance, right? So usually this is a redox reaction, right? When these substances combine, they have to change their oxidation states in order to combine it and organize their electrons, right? So there's our example, right? We've got mercury plus oxygen gives us mercury oxide. Okay, what gets oxidized and what gets reduced. So I'd like you to determine that real quickly, and you can pause the video if you need to, and we'll go on to the next reaction. So our next one is the opposite of synthesis. It is decomposition, right? So in decomposition we have one substance that breaks down into 2 or more. Usually this requires some sort of energy or energy source or heat or something like that in order to make it do that. In this case, right, we have ammonium dichromate, right, and it breaks down into these products here. Okay, so, right, decomposition, opposite of synthesis. This is also generally a redox reaction, right? For things to break down, they generally need to change their oxidation states, and generally it's to a more stable state, right? That's why they would do it. So, again, determine what gets oxidized and what gets reduced. Pause the video if you need. Alright folks, so here we have a single displacement reaction. Okay, we've looked at single displacement reactions, and a lot of times this is where one element replaces another, right? A lot of this has to do with the activity series. Okay, so in this case, if we put copper solid in a silver nitrate solution, that copper is a much more reactive metal than the silver, so it will react, okay, and replace the silver in the solution. You can see a picture of it there. Again, what gets oxidized and what gets reduced. Take some time to figure that out. So here's our 4th type of reaction. It's called double displacement, or sometimes it's called metathesis if you want to get all fancy and stuff. Alright, this is where 2 compounds exchange partners, and usually this occurs in a solution, and that exchange of partners results in what's called a precipitate. This is not a redox reaction. If you look at the 2 examples below, and you look at the oxidation numbers of all the elements involved, none of the oxidation numbers change. Remember that a precipitate reaction is just the result of ions being attracted to one another more strongly than they are attracted to the water. So this results in a solid forming from 2 aqueous solutions. Alright folks, so we are to our last type of reaction, which is combustion. And combustion is exactly what it sounds like. It involves flames and fire and all that kind of stuff, right? This is a redox reaction. So, here's our outline, right? You have a carbon compound burning with oxygen, and the products are generally CO2 and water. An example down here is the burning of methane, right? Which you can see over here on the right side with the Bunsen burner. So I want you to do this because this can be a little bit of a challenge. What gets oxidized and what gets reduced? The results may surprise you if you're able to calculate up the oxidation numbers. And we'll be debriefing this on Wednesday, real quick at the beginning of class. And thanks for tuning in, folks. I hope you have a great day, and we'll see you on Wednesday. Bye-bye.